Okay, so to recap, we already got the data from Twitter that we have in R. So if you missed that, then you need to go back to my previous video on how to install Twitter R, which was a little bit challenging. But after that, now we get a data mining tweets variable containing 500 observations with 16 columns, and can do further analysis with this data. So let's go back to Gaston Sanchez website and continue. So we are from this step, but since we already converted it to a data frame, then I will skip the XML part. So let's go forward and to the text mining. Now I need to make sure that this TM or text mining package is already installed. So let's see it. Okay, it's not there, so I'll need to install this TM package. Okay, it's done, and I'll try to load it. Okay, this should be good. Okay. Okay, so I guess we can try to use print and inspect. No, or maybe inspect. Okay, so this is the resulting corpus, just the first 6 documents after we did the white space stripping, but this is not very interesting, so let's try. Moving on to step 3, where we will do lower casing. So maybe data mining 3, and I will TM map that to lower. Because this should be from data mining 2. Okay. And let's try to display the values of data mining 3. Just the first 6. Okay, so it's all lowercase. So in this case, please be aware that the URLs may not be valid at this time due to the lower casing, but depending on what you want to do, this should be okay. So let's try doing it one more time, and I will map from 3 to 4 using remove words with the stop words from English. I think this should be okay. Yeah. I don't know why this encountered errors. Let me try that again. I hope that's just a warning. Let's try showing that. And no. Okay. I think there's an error here because some of the tweets are not valid UTF-8. So I guess that's where the error comes from. So, but not all tweets are affected. I guess, let's say that most of the tweets are affected in this case. Maybe retry that again using English. Or maybe let's try whether this search tweet R has a different method to make it use a more UTF friendly operation. Okay, there's no encoding related parameters here. So I'll try to skip the stop words operation and we'll just go to remove punctuation. I hope this does not give any errors. Yep, I think that's much better. So let's inspect that one. Okay, so we have no punctuation and all the URLs are jumbled on together. And maybe after this, let's try making the stop words removal again. Well, it's still okay. And the next one, let's try removing the numbers. And it's still error again this time. But I guess it won't be functional if the data is many encoding errors. So maybe I'll try to diagnose how to make this error go away. Iya, Mangga.
Ngapain, Mas?
I think this is a different error because the remove number function is not found. Oh, I think it should be remove numbers instead. Okay, that works. So let's try inspecting. Okay, so these are the Twitter tweets without any numbers, and everything is lowercase, but we cannot get the encoding problem go away. So I may revisit that later. But let's continue, and you can have a term document matrix to create a matrix with the terms as the rows and the documents as the columns. And also the other way around, the document term matrix, don't confuse them. So it's basically a transposed version of the term document matrix. So after that we can do classification, cluster analysis, association analysis, and so on. So let's try how to do that. Maybe just try term document matrix from the corpus that we also already had. Is it possible? Well, that doesn't work, so let's try. Okay, so first we'll try to make a word cloud. I think this is quite interesting. So first I will install the packages. Word cloud. And then I will also install our color viewer. And on step 2 we already did that, so let's skip to step 3, and we already did that by getting the text. So step 4 is create a corpus. We already did that, and now what we want to do is create a term document matrix. This is what I just did, so I don't know why it was not. Let's try using TDM. And I think it's nice thing because the term document matrix already supports parameters that you can control the pre-processing required, like remove punctuation, stop words, and remove numbers and to lower and such. However, when I tried this one before, it doesn't work. Let's try why is this happening. Okay, so I guess I should try to redo the step 5 by doing maybe like content transform was too lower on the data mining 3. Okay, let's do this content transformer too lower. That works, and let's try redoing the step 4 using stop words. Three to 4K. Well, we still have errors here. Okay, so I think I will just go back to the word cloud example and try doing this from the original corpus. So from this TDM, I'll go straight to data mining corpus, and then I'll put controls here. Punctuation true. Stop words C machine, maybe let's say data mining, and stop words English, remove numbers true, and to lower true. Let's hope this works. Okay, we still have errors here. Curious, huh? Okay, let's see if this actually works. Data mining TDM, and wow, that's a large matrix. Let's just try to open it anyway. So actually, well, some of it does work. So yeah, it does work. So I'm not exactly sure why we have errors here, but I hope I can address that in the later videos. But at least at this point, at least some of the words are correctly transformed into the term document matrix. So we have a list of words here as rows. So we have 1138 rows or words or terms, and we have 500 columns where each column represents the document ID, and the values here represent the number of times that word or term occurs in that document. So in this example, the action here, the word action appears in document number 11. So let's try to confirm that. So we have the data mining tweets, document number 11. Oops, sorry about that. So you can see that it correctly puts the tweet number 11, so it contains action. So if you see here that the number 11 also, document number 11 also contains the word signed and process mining and such. So let's try whether that is true, that the word signed, okay, this is the word signed, and signed number 11, okay, so this is true. So this is how the term document matrix works. Okay, so based on this matrix, we can get words and their frequencies. So we can get the M for, say, signed. Can I do this? I think it's because it's not actually the row label. How to get a row using label? Does it have row names here? Yeah, they do have row names. Maybe I should use this. Okay, so I need to use the comma. So to get the sign for document 11, it gives 1. Okay, that's correct. Okay, and let's go back here. Let's obtain the word counts. So let's see what the work frex looks like. Okay. So maybe I'll use a head on here. So it gives you the list of 6 most frequently occurring words. Now let's create a data frame with words and their frequencies. Now you can see this, it has been reshaped. So we have the word here and we have the frequency here, and we can get the particular data by doing this. Okay. What if I miss the comma? Okay, you can't. And how many times the word signed appears? Just one. How many times the word people appears? 3, and so on. So now, after we have this data, let's plot the word cloud. DM word, and we have frequencies for each word. Random. There's no. That's weird. Oh, I need to use the library. Okay, and let's try that again. Okay, that's right. So first we need to have the word and frequencies and the random order. Be false. And the colors, let's use river, long, 8, dark 2. Okay, and this is the plot. Yay! So this is the plot, the word cloud plot for the data mining. To be honest, this is not very interesting. We need to have more data, so 500 tweets is not very interesting to plot the word cloud from, but it's okay. Let's see what warnings are there. So maybe instead of plotting all 1000 observations or words, maybe I'll just need to plot the first 200 words. Maybe this will be more interesting. Okay, this is much better. So, okay, so this is much better. This is much cooler. Okay, so I think the size of the plot area also determines how many words that you will fit. So let's try 300 words instead. And now this is right. Yeah, this is very cool. I'm happy about this. So I guess this session is pretty good. We can use the text mining or TM package, and we created a text document matrix from the corpus, and also making pre-processing like removing stop words, to lower, removing punctuation, numbers, and so on. Although there are still some issues with UTF-8 encoding that I haven't really understood yet. But even if we just go through that and make the term document matrix, after all, the TDM, we can input that into the word cloud package, and using the brewer colors to make this quite beautiful word cloud. But now I'm curious, what if I don't use the colors parameter here? What will happen? Oh, you just have a black and white. So I think this one is much better looking. Or maybe try to, if there's dark too, there should be a dark one, I guess. Nope. Maybe light one. Or light two. Really? How many palettes are there? Let's try to find out then. Viewer palettes. So okay, so these are the list of palettes. So let's try maybe pastel 2. And that's too light. Maybe let's try accent. Okay, that's a little bit better. But yeah, dark 2 is I think it's the best. Okay, see you on our next session. Thank you.